Welcome back everyone. In the last video I introduced the Birdy's Chalkboard thought experiment in an aim to explore what systems can be conscious and where in those systems consciousness can be found. I will suggest watching the previous video before continuing to watch this one. A link can be found in the description. I think there are several solutions to this philosophical question. We shall begin with the most obvious, but in my opinion the least interesting solution, which would be that the system could never be conscious to begin with. So neither the artificial neural network on the computer nor the one on the chalkboard could ever be conscious and merely appear to be so. This might be the truth of the matter, but it is the least encouraging solution of all. The solution shuts down all avenues of research, evaporating any hopes of developing an artificial consciousness. However, this solution can be somewhat undermined by the idea of a connectome, a complete map of the human nervous system, every neuron, every synapse, every neurotransmitter and more. The connectome, once understood, could then be simulated on a computer and thus also a chalkboard. So if humans are conscious and we can create a complete connectome simulating an entire human brain, then the problem of the chalkboard consciousness will continue to avail us. As once again we must ask, where is consciousness in our chalkboard system? Which leads us into our next solution, a slight variant of the last. Perhaps the human brain cannot be understood by simply observing and explaining why every possible interaction occurs using the connectome model. A property is missing when we calculate our artificial neural network on a computer or when we transfer it to the chalkboard, preventing an artificial consciousness to exist in the first place. This is the spiritual solution to the chalkboard problem. Consciousness cannot be understood by the scientific method. It has some mystical influence altering the state of the system and consequently generating consciousness. I'm sure few of us would agree that consciousness is entirely independent of the brain. Clearly, neuron firing speeds have an influence on what timescales we are conscious of. You cannot be conscious of something which has been and gone in such a short time before a neuron has time to even react. You are not aware of every passing nanosecond, heck, not even every microsecond, millisecond, or perhaps an actual second. A frequent mystical argument is that the brain is like a receiver, which taps into some form of consciousness field permeating the universe. I must then ask, if this field influences the brain due to the brain's receiver-like properties, which in turn forms our consciousness, would this influence not be at least observable in the brain, thus would appear in our connectome model? I believe if there was some mystical influence, we should at least be able to observe its effects on the brain, even if we cannot explain it. Thus we could factor it into our chalkboard network and generate consciousness once more. Our search for the location of consciousness continues. To bring this influence into a more scientific light, generates our third solution. It is the stimuli which we feed the network that produces consciousness. In effect, the essence of consciousness is created by the environment it is in. This is a very interesting conclusion. A hallmark of consciousness, internal thought, often appears in forms such as the inner voice or inner envisioning. Forms which mimic our real senses, those which monitor the external world around us. I believe this is by no coincidence. Environmental stimuli no doubt help create our conscious experience, but once consciousness is generated, and in the absence of any stimuli, consciousness does not cease to exist. In fact, it is more active than ever. We can now remove any environmental influence to our system by making a simple modification to the chalkboard experiment. The network now must operate upon a stimulus contained within the chalkboard. For our simple thought experiment, we will say that the network now operates upon a noughts and crosses board. The network observes the game's state and can also act to change the game's state. If you believe that this stimulus is far too simple to generate consciousness, you're probably right, so instead scale this stimuli to as complex as you like, perhaps going as far to simulate the real world itself, as long as it is entirely self-contained on the chalkboard. In other words, everything that can possibly occur with our stimulus is once again dictated by a set of mathematics calculated on the board, and no external influence can interfere. Of course, a game such as noughts and crosses needs two opponents, and if the chalkboard artificial neural network is playing you, the writer, upon the chalkboard, then once again you are introducing your own consciousness into the system. Whereas our aim for the chalkboard network is to have a consciousness entirely independent from the outside world. Thus you must now replicate the network so it plays a variant of itself. If this system remains conscious and all of our system now resides within the board, then once again we must ask, where is consciousness? We reach our last solution. Of course, due to the previous points, we still assume that our chalkboard network remains conscious and that we have removed all external influence which could introduce consciousness from the outside world into our chalkboard system. We must now reach our final conclusion on where consciousness is in our chalkboard. To recap, our artificial neural network was initially run on a computer. We know that on this computer our network was said to be conscious. We transferred this strict mathematical algorithm processed on a computer to a writer propagating the maths on a chalkboard instead. By process of elimination, We know that consciousness must reside in some similarity between the two conscious systems. What are these similarities? In both cases we have a calculator performing the mathematics. Although this calculator cannot introduce their own consciousness into the system due to the unwavering algorithm, we know that our artificial consciousness cannot exist without the maths being propagated. Thus, by ceasing to calculate the mathematics, our network's consciousness is effectively paused. We must also have a sufficiently complex stimuli which evolves using a set of rules which must also be calculated. The conscious networks can observe and influence this stimulus too, again following a rigid set of rules. Finally, we have a highly complex artificial neural network itself. This network must be sufficiently complex to host a consciousness. So we have our three prerequisites. We can deduce that the similarity between the systems, which directly interacts with consciousness, is the algorithm itself. Thus consciousness must be residing within that algorithm. But what does this mean? Well, what we are saying is that there is no real physicality to it, except the physical system calculating the maths. The network has an initial state which gets continually updated by calculation, and the stimulus feeds it with information. Once active, a stable consciousness must be self-sustaining as long as the algorithm continues to operate. In effect, the last solution is that some forms of maths are actually conscious and can be manifested in various ways. Our brain, the computer, the chalkboard, all ways of running similar conscious algorithms. Clearly, consciousness is not dependent on the medium it is calculated in, it is the more ethereal mathematics, the rules governing the system's evolution. This leaves only one outstanding issue to this problem: predictability. If the evolution of the conscious system is following a set algorithm, then we must be able to predict its actions, eliminating the notion of free will. Alas, we can ensure the existence of free will by considering two subtle properties in our network. In the real world, we cannot calculate our equations to infinite precision, thus the outcome of the network is dependent on the level of precision we choose. This implies the network must be a chaotic system. We know the rules by which it evolves, but the most infinitesimal change in state or stimuli or initial conditions eventually yields a wholly different behaviour by the network, making it as unpredictable as the weather in 1,000 years' time. The second consideration is that the algorithm cannot be shortcutted. You must calculate each and every state of the algorithm to evolve it to a future state. This is known as computational irreducibility. Any approximation will not suffice long term due to the inherent chaos of the system. By trying to predict the behaviour of another algorithm into the future, you must in turn run the same algorithm yourself. Once again, you become the propagator of maths, and you have now fulfilled the requirements. So by propagating the same mathematics, you have just created another consciousness, which is unpredictable as the first. Of course, computational irreducibility does not refer to the speed at which calculations are performed, only the number of calculations in total. So if you were to run the second algorithm on a faster system, you may be able to predict the actions of the first. But this is analogous to observing two versions of yourself in identical parallel universes, except that one is running at a faster rate from the perspective of you observing externally. Now, you can predict the actions of one version of yourself from watching another. To use your predictions, the systems must be able to interact in some way, inducing infinitesimal changes, which in turn change the behaviours of each state, altering their actions in the future to once more be unpredictable. The combination of chaos and computational irreducibility restores the notion of free will in our mathematical conscious solution to the chalkboard problem. In many ways, the strangeness of this idea rivals that of even the unexplainable mystical solution. I'm sure you will agree that this solution is really quite profound. In effect, by providing information about the stimuli to the network and then calculating the network states, the system as a whole becomes conscious, irrespective of which means is used to calculate it. To clarify, we have not stated how the network became conscious in the first place, we are only saying that once a conscious algorithm is established, these are some of the conclusions. To reiterate, I am not stating that the general form of mathematics is innately conscious when calculated, it must be trained to be so. Only a set of specific algorithms are actually conscious, and these must be found by training unconscious networks capable of hosting a consciousness into a conscious state. Once a stable consciousness develops within the system, it can generate its own internal stimuli to sustain the process. To those asking whether this is materialism or dualism, I will say it is instead the properties of emergence, something more than the sum of its parts, but still governed only by its constituents. Thank you very much for listening. Please feel free to leave any further discussion in the comment section or any other solutions you may have to this problem. I will try and respond as much as possible. In the next video, we shall start discussing some geometrical interpretations of artificial neural networks. I look forward to seeing you there.